We are live. Assalamu alaikum, everyone. Welcome to today's online conference titled Artificial Intelligence Introduction and Examples. We are especially honored to welcome our great speaker for today, Mr. Riyadh Baghdadi, a real example for us Algerian young people, hoping to dive into interesting fields such as AI. So, Mr. Riyad Baghdadi is an assistant professor at New York University Abu Dhabi, global network assistant professor at New York University, and research affiliate at MIT. Mr. Riyad, it's our pleasure to have you with us, and the stage is yours.
Thanks a lot. It's my pleasure to be with you today. I'm very happy to be with the School of AI. It's really big pleasure. Let me just, I think, let me share my screen this way. Okay, you can see at least the screen. So it's really big pleasure for me to be with you today. Like when you guys at School of AI invited me, I couldn't say no. I really like what you guys are doing. I like the fact that you have technical content as club. You present technical content, which is really very interesting. So I highly encourage students to kind of join and uh, practice, learn, participate in this type of events and activities because this is basically how they can learn. But before I start, I usually like when I'm giving these presentations live that you guys write your comments on the screen so that I can see what you write. Uh, so my presentation today is kind of a general introduction to deep learning, an overview of deep learning and applications. This is not a very technical presentation. Last year, I gave technical presentation with School of AI about the research that we do using deep learning for automatic compiler code optimization. Maybe there will be, inshallah, in the near future, other more technical presentations. But this presentation is really an introductory presentation to those of you who don't know deep learning or just want to discover kind of applications of deep learning. If you know deep learning, it's still interesting to follow. I think you will see some applications, some interesting applications. The whole point is to motivate you to learn the field of deep learning and so that you become an expert, inshallah, in this field. And so maybe also before starting this presentation, I think as someone who is studying in an engineering school or an engineering field, it's very important to keep in mind that all what we are doing here, all what you are studying in your at school, is to prepare you once you graduate, inshallah, to become someone who can build systems, who can build full system that solves real problems. And so a part of what you can learn or what you should learn is not only the theoretical kind of aspects of what you study, but also the practical side. And it's very important to try to balance these two. So whenever you have the opportunity to practice whatever you are learning at school, you have to do so. You should do so. Especially if you study something, you want to kind of explore how this thing could be applied in practice. There are a lot of examples on the web. You can watch YouTube videos. You can get a lot of tutorials on how to apply things in practice. So it's very important that you guys practice all what you learn, so that when you graduate, you actually use what you have learned to solve real problems. And so with that comment, let me start with the presentation. So this presentation is part of a tour that I'm giving in Algerian universities. Today I have been invited by the School of AI, so it's kind of continuation to these different presentations. But before I kind of continue, I just want to know what's your level, guys, in deep learning or AI in general. Can you type in the comments whether you have used AI before, any AI tool or any AI app other than ChatGPT? Let's exclude ChatGPT. if you have used any AI tool or any AI app before. And also in general, just let me know about like what's your level in like knowing deep learning and AI in general. So I'll wait for your answers in the chats. So for this question, who has used AI before? All of you should say yes. All of you should answer yes, even without ChatGPT, because I think all of you have used YouTube, all of you have used social media, all of you have used your phone to take a camera. So whenever you watch a video on YouTube, YouTube is using machine learning to recommend other videos for you. So the way YouTube picks similar videos is using machine learning. Whenever you take picture using your phone, there is an image processing kind of filter or app that improves that image even before you see it the first time. Like whenever you take it, it's improved automatically using a filter that's an image processing filter. And so we use AI every day. We use machine learning every day. Another question is, do you guys think that there are any AI or machine learning based algorithm? So whenever I use the term AI here, I mean machine learning based. So I'm using, I'm focusing mainly on machine learning. So do you think that there are any machine learning based or deep learning based algorithms or methods that are used in US hospitals and pharmacies and that are already approved by the FDA? FDA is the Food and Drug Administration. This is the institution that approves medical devices and medicines and so on in the US. Do you think there are any algorithms or methods that are already approved and used in the US in US hospitals? You can answer in the chats. There are actually more than 520 algorithms already approved. And this shows that machine learning and AI is not just something that is emerging, but it's something that is already applied. It's something that is already solving a lot of problems in real life now today. If you look at these applications, radiology is the main kind of example of application where machine learning is used in the medical field, mainly to analyze medical images. This is because at least the previous generation of deep learning succeeded a lot in image processing applications. The new generation based on transformers made also a lot of progress in NLP, but applications that are approved by FDA, these are applications that have been filed like 10 years ago. So at that time, mainly image processing applications, like machine learning was really excellent in image processing applications. And so in the near future, we will see kind of a huge jump in applying machine learning to other medical problems using new techniques like transformers and large language models and so on. So why is talking about AI important now? Why you really have to learn this topic? Because this is the golden age of AI. Every kind of when you look at technology like electricity, when electricity appeared, it changed our lives. Like the world before electricity and the world after electricity are completely different. After electricity, new jobs appeared, the new tools appeared, a lot of things changed. This was not the case before electricity. And so the same thing happened or will happen with the emergence of AI. New jobs will appear, new tools will appear, and some old jobs will disappear. And so it's really the right time for you to learn this area and to become really expert in this area so that you can contribute to this wave, technological wave, and be part of it and be kind of in the front of it. And this kind of technological shift happens rarely. It doesn't happen a lot. So it happens like once in 50 years or 60 years or 70 years. And so it's really golden, kind of golden opportunity. If you miss it, it's very hard to find another one in the next 20 years or 30 years. And so it's really, really golden age for, if you're interested in this topic or in this field, it's really great time to work in the field of AI. And so in this presentation, I will briefly give you an introduction of what's deep learning, and then show you a bunch of examples, and then few challenges. And so deep learning is part of artificial intelligence, and the goal of artificial intelligence is to enable computers to do tasks similar to what we humans do. And then within artificial intelligence, there are a lot of techniques. One of them is machine learning, and the main goal of machine learning is to enable computers to learn without being explicitly programmed. And even within machine learning, there are a lot of techniques, and one of them is deep learning. And the main characteristic of deep learning is that it's built or it's inspired from the way neurons work in the human brain or in animals. And so that's kind of the main characteristic. And it's inspired from biological neurons. As you know, neurons take a bunch of signals as input and then sums those signals. And then if the sum is above certain threshold, the neuron will fire as an output. And so we take these neurons and represent them kind of mathematically. And using that, we create a network of neurons. This is an example of a network of neurons, or we call it a neural network, un réseau de neurones. And so each one of these circles is a neuron and these lines are connections between these neurons. And all of this is a neural network. So the neural network takes an input, for example, an image, and produces an output. In this case, it takes an image and produces as output the name of the person, or basically classifies the person. It knows who is the person. And the way this neural network works is when it takes an input, in these layers, it first tries to extract very simple features that represent the input, very simple characteristics that represent the image, for example, edges. And then in the next layers, it tries to combine them into more complex features, like, for example, eyes. And then in the next layers, it tries to combine those features into even more complex shapes, like a part of face or nose and so on. And then in the last layer, it composes all of these kind of parts of faces to create a full face, and that way it recognizes the person. And so this is the power of these neural networks, is that it learns these features automatically from data. And there are algorithms that are used to train these neural networks. When we say train, that means adapt these connections between the neurons so that the neural network can do the task that we want it to do. Because these connections between the neurons are what defines the function or the functionality of the whole neural network. Think of the whole neural network as a function, mathematical function. It takes an input, and then it produces an output, and the behavior of that function is defined through these connections. And these connections are learned from data using algorithms like gradient descent and backpropagation and so on. Now let's look at a few examples. The very classical example is the example of classification, where you have a neural network that takes an image and just recognizes or classifies that image. In this case, it recognizes that it's a cat. Another example would be to have neural networks in driverless cars. In this case, you can have a network that identifies cars or identifies pedestrians or signals. Here we have another example of a neural network in the driverless car that performs multiple actions or tasks. In this case, it's free space detection. This is intersection detection. Here we have path planning. And the difficulty here is that the neural network has to run in real time while the car is driving, which is, so we want a neural network that is very precise in performing the task, but it has to be very fast. Here we have dynamic object detection. Here we have mapping and localization. Here we have driver monitoring. So when the driver is sleepy, we can send them a kind of notification or notify them. Okay, this is another example where we use deep learning in drones to avoid obstacles. So as you see now in the video, the drone will avoid different obstacles, will identify what are the obstacles and kind of tries to avoid them.
3, 2, 1, launch!
And the nice thing about this example of application is that this was done by students at the bachelor level, kind of in their third year, second year students. So all of what I'm showing is not difficult. You can build all of these models. They are not extremely hard to build. You have a lot of data available on the web. You have open source models. You have a lot of tutorials, a lot of books, a lot of online courses that you can follow. So all of what I'm showing here are things that you can build. Another example is aerial object detection. So this is object detection from drones. Another example is generating images. As you can see, the quality of these images is quite good. This is another example of generating images. This is another example of generating images using generative models. Generative models are models that either generate text or generate images or generate audio or video. In this case, I asked the model, this is DALI 2, I asked the model to generate this image. And as you see, it's quite realistic. Now we have more kind of realistic, I think, more sophisticated models. Here I asked the model to generate the picture of children playing soccer in Algeria, or Algerian children playing soccer. And so as you see, it it thought about drawing the Algerian flag here. This is another example of Algerian children celebrating the Independence Day. Do you think there is any issue with this image? Can you identify any issue here? Maybe you can type in the chat. You can see any issue. So one of the issues is that this child here in the middle, he has one hand on the right, another hand, and then he has one left hand, another left hand, and this one has one right hand, another right hand. So this was, I think I used DALI last year. So at that time it was not very sophisticated, but I'm sure it has improved. Like maybe if you try it this year, maybe it doesn't have these issues. But these models are improving very fast. I think all of you know this by following what's happening in the space. This is another example of generating videos using Sora. This is another model proposed by OpenAI. And as you see, the quality of generated videos is quite good. Okay, let me jump these few examples because I think you know them. This is Google Duplex. Now, many of you know ChatGPT. ChatGPT is another example of generative models. It's text-to-text model. It takes text as input and generates text as output. And the way it was trained is that we take sentences from the web and then we remove one word from those sentences and ask the model to predict that missing word. It's called next token prediction. And then we repeat this kind of task hundreds of billions of times or trillions of times. And over time, the model will learn the meaning of these words and learn the meaning of every word so that it can fill the gaps. Because it cannot fill the gap unless it really knows exactly the meaning of these words. And the term meaning here means create a representation of this sentence and then use that to predict what's the missing word. So we have published the paper about 1.5 years now, trying to answer the question of whether ChatGPT can answer exams, can do well on exams that we have at New York University, Abu Dhabi. So do you guys think that if we ask ChatGPT to answer the exams, give it the exams that we give to our students at NYU Abu Dhabi, do you think like it will do well? It will be the same like students, below students, better than students? Can you answer in the chat? So is ChatGPT better than students in exams, worse, similar? So we did this study last year, and the answer was that in many cases, ChatGPT is actually similar to students. So here in this graph, you see in green, in blue, you see the average of students that they got in these exams. So this is computer science. These are the different courses. This is computer systems organization, structure machine. This is operating systems. This is introduction to computer science. It's like algorithmic. And so in green is the average ChatGPT grade, and in blue is the average student grade. So as you see, it's quite close in many cases. In some cases, it's not, and in some cases, like there's big difference. And in these cases, this is the case of discrete math, because at that time, with that ChatGPT version, it didn't have reasoning capabilities. So to be able to really do well in math, you need to reason, like you need to make plan and reason. And so at that time, ChatGPT didn't have that capability. Now, with the newer versions, ChatGPT has this capability of reasoning. And so this is another example where ChatGPT managed to get better than, basically USMLE is the equivalent of the Residana exam in Algeria. The US medical licensing exam. And so this is kind of the progress of different models. In 2020, we had a model called GPT Neo that got 33 out of 100. And so in the USMLE exam, if you get more than 60, you pass. And so over time, models have improved gradually. And then at some point in 2022, the first model, MidPalm, got 67, which is the first model that passed the threshold, and so it succeeded in this exam. And then after that, MidPalm 2 got 85, and GPT-4 got 86, and now they just keep improving. And so now these models can answer properly kind of the USMLE exam. So let me quickly move over this. I think all of you know this stuff. So let me show you some examples in health sciences. So the very classical example of using deep learning in kind of health sciences is breast cancer detection. So you have this image, X-ray image, and then the model will detect cancer. These models have an accuracy of 79% compared to the expert accuracy of 80%. So it's quite good and high accuracy. The surprising thing is that these models can predict cancer 4 years before the cancer, 4 years before the cancer actually appears, or before the cancer becomes visible. And so here in this case, this is the same patient, but the image has been taken 4 years before this image. And so the model is predicting that here there's a high probability that there will be cancer here in 4 years, or in few years. And so this is very good and can be used in predictive medicine. This is another example of using deep learning models for skin cancer detection. And these models match expert accuracy. And this paper was published in Nature. So it's quite high quality paper. This is another example of using robotic surgery. This doesn't use deep learning, so I'll skip it. But basically, this is a robot that makes surgery. This is another example of diabetic retinopathy, where people who have high blood sugar, they have that affects the retina. So diabetes have very high bad effect on the retina, and so what usually they have to do, they have to go to the eye doctor, and then the doctor has to kind of inspect their retina to make sure that it's not impacted by their diabetes. And so Google has proposed a model that can detect diabetic retinopathy, which are issues in the retina caused by diabetes. So this model can detect those issues with an accuracy of 90%. And you might say these models are just things that are developed and in research labs are never used. I know doctors in Algeria who are actually using these models in Algeria. So there are doctors who go in rural areas, and they take pictures of the patient eyes, and then use these models to quickly identify which patients have to go to see the doctor and which don't need to see the doctor. Just because we don't have enough specialists that can go to these rural areas, and so this is actually being used and deployed in Algeria to cover a lot of rural areas. So this is Professor Rashid Malik. He's using this in STAFE. A couple weeks ago, I was giving this presentation there, and he was present, and he told me about the story and the fact that they actually use it. So let me skip all of these. This is another example using deep learning to decode the brain wave signals. So this is a patient that cannot move, and so she can she can think about what she wants or what she wants to say, and then deep learning can decode her brain waves to generate speech, to generate actions. Let's skip that.
Tonight,
this is mobility restoration. This is robotics for mobility restoration. This doesn't use deep learning. So all of this stuff is classical robotics, but usually kind of advanced robotics uses reinforcement learning or deep reinforcement learning. So you can plug deep learning there. This is AI in drug discovery. It's also used in drug discovery to figure out, for example, if a molecule can interact with target. For example, if you want to develop a kind of a medicine, usually or drug, usually that drug acts by changing the form of a protein. And so the protein is the target here, the protein is the target, and the drug, you have your molecule here. And we can use deep learning models to figure out if the drug can change or can interact with this target. And if there is an interaction, then we can use this drug to actually change the form of that target, which would mean that you can use it as drug in this case. So let me go quickly over this okay. Now let's talk a little bit about the challenges. Now that I showed you a few examples, let's see a few challenges. So one of the main challenges is that to train these models, you need a lot of data. You need a large data set because these models are trained through data. For example, if you want to train a model to detect cats, you have to give the model millions of pictures of cats and other things so that it learns to distinguish between the two. And so, like usually the key question is, if you want to build a model to solve a particular problem, the question is, do you have data? If you have data, building the model is easy, or at least is much easier. If you don't have data, then you have to work to collect that data, which is usually the hardest part in these projects. There are large training costs for things like ChatGPT models, but for all the other models that I have shown, usually you don't need very large training costs. And these models still make very obvious mistakes. Let me skip the ChatGPT cost, but I think you guys know that one training like something like GPT-3, which is now a little bit old, just one training takes more than 4,000 GPUs or GPU months, which cost about $4 million if you want to do the training on the cloud. And usually, as you know, if you are training a model, you have to try a lot of times, kind of lot of architectures, lot of variants, and so you can multiply this number by 100 or 1,000, and so the actual cost is between 400 million and $4 billion to train just something like GPT-3. And an example of kind of silly mistakes that these models can make, you can have a model that correctly classifies that this is banana, but if you just add this sticker here, the model will predict that this is a toaster, not a banana. And this is known as adversarial attack. So you can actually, there are techniques to design these stickers so that they fool the model. And there are things like one pixel attack. You just change one pixel in the image to fool the whole neural network so that it makes mispredictions. In this case, if you have this stop signal here, if you just add these two little white boxes and two little black boxes, then the model, instead of predicting that this is stop, it will predict that this is speed limit 45. This is another example of adversarial attacks and obvious mistakes. So now if one of you wants to learn this topic, I have collected here a few sources and links. Like the very first step, this is for people who are not engineers. I think most of you here are engineers. So let me go over this list. So like the basic is to master your undergraduate courses, because these are the basics. Mathematical concepts like and topics like linear algebra, statistics, probability, these are also basics, like things that you need, because all of machine learning is built on top of statistics, probability, and linear algebra. And then as programming language, you need Python. So if you want to kind of learn this area, you should become very comfortable with Python. There's this free course that you can follow if you are not familiar with Python. And then AI is a very, very general area. There are so many techniques. Machine learning and deep learning is just one of them. And so it's very good to learn about the whole area of AI and learn about all the techniques, because there are so many. And for each particular problem, you should pick the right tool. You shouldn't use deep learning to solve every problem. You shouldn't use language models and large language models to solve every problem. That's not a good idea. Instead of that, you should pick the right tool to solve the problem you have. And to be able to do that, you need to take a course that covers all of AI. And so this is really, really good course from MIT that gives you a general overview of AI. And then you have this course about machine learning. It's the machine learning specialization. It's a very good course by Andrew Ng. And then you have the deep learning specialization. It gives you all what you should know and you need to know about deep learning. And then PyTorch is the library that is being used now by default. And so you have this kind of tutorial about PyTorch that you can follow. There is a JAX framework. So there is PyTorch, there is TensorFlow, and there is JAX. TensorFlow was widely used, but now is dead and is kind of not used a lot anymore. PyTorch is the default. Everyone is using PyTorch. All people around me that I know use PyTorch, except people at Google. People at Google in the past used to use TensorFlow. Now they use JAX. JAX is an emerging framework. It's quite good also. but PyTorch is still kind of the default used there. Okay, so that's all from my side. Let me stop here, and if there are any questions, I will be very happy to answer you. So let me stop sharing my screen. Stop sharing. How can I stop sharing? Okay, so let you.
Thank you. Thank you very much, Mr. Riyad, for your great presentation. Thank you. Like those, it was like there were very great, interesting applications of AI in different fields, medical, like medical field, and the field of drones. Very exciting. And we have a couple of questions. So, for the first question, it is asked by Amal. It says, "How can education systems adapt to the current revolution of AI?"
Yeah, I think this is a very good question. So there are multiple parts here to answer your question. I think the first part of it is how can we take benefit of AI to improve education, and there's the other part, which is what's the negative impact of AI on education. For the first part, I think using things like ChatGPT as assistants to help you learn faster is great way to learn very fast. It's very, I think, like whenever you have topic, you start learning about that topic either in school or like following presentation or YouTube video or whatever like tutorial you are following. You can ask questions very quickly and get answers if you don't understand particular thing. So using these assistants to help you understand specific things in that presentation, just take kind of screenshot and ask ChatGPT about this thing or that thing. This is a very good way to make a lot, like very quick progress in understanding. This is how we can use it. We can use it also in learning programming languages, in learning languages in general. So all of this is good. The negative impact, yes, I think it will have quite big negative impact. We don't know how to deal with that. I start to notice it in students, like first year students and second year students. This year, they seem to be addicted to ChatGPT. Like whenever I ask them in class, whenever I ask them question, very simple question, they use ChatGPT to answer that question. So I start to see the impact, the negative impact. So it's up to us to, I think, to learn how to adapt, because if we don't do that, then basically as student, if you don't use it the right way, you wouldn't learn. And if you don't learn, someone else will learn better than you, and they will basically take the job. And so like if, for example, if you have an assignment where we ask you to write a model, machine learning model, to solve a particular problem, and you go to and use ChatGPT to answer that problem or to solve the assignment. You can do it now as while you are a student, but there are two problems. First, these tools, we don't know if in the next few years, like 2-3 years, if they will be able to 100% be able to write correct code. Now they can write simple correct code, simple, but if you go start to do something complex, they completely fail. And if you have tried to build any complex project, you will notice this. For very simple things, they can do them. But as you go to complex things, they fail. Now, we don't know if in a couple years from now, they will avoid this problem or not. They will be able to avoid this problem or not. There are theoretical reasons why certain people, like Jan LeCun, for example, think that they will never be able to do that because of the problem of divergence. Basically, whenever they make an error, the next prediction that they make will carry that error, but there will be other errors. And so you keep diverging from the correct answer, and just keep diverging over time as like the answer is longer. And so And so we don't know if in the near future these systems will be able to do perfectly these things. So if you don't learn now, that means in a couple of years from now, when you are on the job market, you wouldn't be able to actually solve real problems, and people will just fire you because you cannot solve their problems. And so if you want to guarantee your position, you really need to learn on your own and then use these tools on top of what you have learned to make yourself more productive, to be better, to be able to do more things than what you can do now. But I think there is a big issue coming, and to be honest, I don't know how that issue can be solved. At this stage, we are just focusing at the technical level. In a couple of years now, we would face the other issues, the societal issues.
Okay, thank you. For the next question, is also by Amal. It says about the medical field. How reliable is AI now in practice? Like, how much can we put trust in AI in such sensitive field nowadays?
Yes. So AI or machine learning is better than a human performance in certain fields and worse than human performance in other fields. Uh, uh, so in the medical field, it's still worse than human performance in general, and it's improving very fast. But we still don't have any guarantees. We still have issues like the interpretability of, like, when a model says, okay, there's cancer here, it doesn't necessarily explain. With the new models, the new generative models, they can explain to some extent. But even there are papers that show that their explanation is just fake explanation. So technically, it's not, the model is not explaining how it actually got the answer, but it's just saying what it's supposed to say, what people usually say. There are papers, for example, that took models like ChatGPT or generative models and then asked them to do to add, let's say, two numbers, add, let's say, 16 plus 17, and then the model got some answer. And they have developed very sophisticated model or method to figure out what are the activations that are being activated when the model is making its answer. Basically, exactly understanding how the model is answering that particular question. And what they found is that the model is using some heuristics. It's just like doing very mixed methods and heuristics to mix things together and get the final answer correct. But when they ask the model, how did you get the answer? How did you do 17 plus 16 or whatever number they gave it? The model says, I took 7 plus 6, added them, and then, like, it said what it's supposed, what people would expect it to say, not what it actually did. And so even these generative models are not explaining how they work. They're just pretending to explain. And so we still don't have very explainable AI. So that's a big kind of area. These models still make very silly mistake. If you just change the representation very slightly, they kind of give you the wrong answer. And so there's still some work to be done. So people in driverless cars, they laugh at people in the area of generative models. They say, we started working on building models that can actually be practical. We started doing that like 10 years ago, they say. Until now, we don't have any driverless car that can actually drive in the road, right? We don't have that. We don't have, like, at level 5, which is fully autonomously always driving without any issue. They always can drive, let's say, for 1,000 hours without any issue, or 10,000, or like 20,000 hours, but there is 1 hour where they make an issue. So you cannot use such a car if, like, it drives 10,000 hours and then make crash after that. And so they say, okay, you guys, they say, in generative models, you are building these models will improve and improve and improve, but at some point there will be always a percentage of mistakes that these models will make, and we don't know how to fix those those errors. And so in the field of in the medical field, it's the same issue. And so it's still open to research, although there is like a huge progress that is being made. So
Okay. There is also a question by Ryan. It is about those attacks. It says, I heard the changing just. I heard that changing just some pixels of an image can lead to drastic mistakes in the results of AI models. How do you think we can combat this?
yes, so that type of attacks is called one pixel attack. So the idea, I think that there was a paper published by MIT 5 years ago or something, where you take an image and then you ask the model to predict, let's say, to classify that image, it classifies correctly. And then you just change one pixel. It's called one pixel attack. You just change one pixel in that image, and the model will just completely change its answer. So there's the whole field of adversarial attacks that studies this, studies basically the methods of attacks and the methods of how to protect against these attacks. There are a lot of attacks, not just this one, and each one uses like technique. There are gradient-based attacks, there are black box attacks, there are and so on. And so it's very well studied field. But in general, like the way we should understand it is that these models make these mistakes because they have a representation. But basically, deep learning models, the way they work is they work in two phases. First, they create a representation, very high, or at least a representation of the input, features that represent the input. And then they map that representation of those features to an output. Basically, these two steps. So if you don't learn very high quality representation of your input, then you can very easily kind of perturb the behavior of your model just by changing the values of that representation by adding 0.001 to your matrix of representations. So there is that, and usually these attacks play on this, on like basically just slightly changing the representation. And so one way to avoid that is to build a model that learns a robust representation through pre-training. If you have a model and you pre-train it on a lot of data, it will learn, if you provide a lot of data, it will learn hopefully very high quality features that represent all of that diverse data. And then the second problem of mapping that representation to an output is an much easier problem. So I think the difficult part is in learning the representation. And now with all of these generative models that are being self-trained, self-supervised learning through self-supervised learning, then people, I think going into this direction will help in solving this problem. So probably I'll take the last question and then we can stop there.
Okay. So the last question by Amal, it says, how can we, people of developing countries, do in the AI field using the limited resources that we have to help our country advance in such field?
Yes. So you don't, to learn deep learning and build models, you don't need very sophisticated resources, at least to start. So you can use platforms like Colab, which is free, provided by Google. You just go and kind of use they give you GPUs, they give you CPUs to train small scale models. So usually that's enough to learn at small scale, and it's also enough to train small models. But in the near future, if you really want to build like large models, then you would need GPUs. You will need sophisticated GPUs. So inshallah, there is a plan in Algeria to acquire the necessary resources. It's very important for the country. So there are plans to acquire the necessary equipments. Also for universities to buy their own resources. This will come gradually, so it will take some time, but there are plans for doing that, inshallah.
inshallah. Okay. Thank you very much, Mr. Riyad, for joining us. It was our pleasure to have you with us. And thank you everyone for coming to today's session. See you tomorrow, inshallah, for another exciting topic.
Thank you.